Yes, I guess we can sort of start off with just doing a bit more of an introduction of us. Keeping it short. I mean, I know we've already posted on the Slack channel, but since they can see our faces now, might be a good sort of chance to, break the ice a little. So, yeah, Dan, do you want to sort of explain a little bit of your sort of background and what you'll be talking about tonight?
Yeah, sure. So I'm an engineer. I consider myself kind of a machine learning engineer, which puts me in the AI space. But um, as a CTO of a consultancy in this space, think a lot about AI strategy and where it's most appropriately applied. So I'm kind of a little bit on the tools, a little bit talking to business about how they apply AI sensibly and in the right places and gets them the right kind of leverage. My background has always been in technology, but around consulting, I like building things that people use. So I've been previously in mobile, running my own mobile consultancy, and before that, in generally the data kind of space, which is works. We talk a lot about data in the AI space as well, so that's been working really well for me. And being back at RMIT in this program's been really good. This brand RMIT is really good for me. It's my university where I started out this kind of journey. That's kind of my background. About you, Sam?
Yeah, so my background is it's a bit of a convoluted one. Started off always playing with data, but never really had a bit of a label, and everything from SQL, R, the statistical software, and through to Python, and then eventually Google named us all data scientists. So then, worked my way through consulting in there, and building everything from machine learning models to business intelligence. Then was in the sort of inception with that open source of TensorFlow and all the artificial intelligence tool sets. So obviously client appetite change and the industry change, as we're all sort of here realizing that there's a big appetite now for machine learning, deep learning, and AI in general. And that's, everything from retail banking to greater finance and government, which is where I've sort of played a lot of the domain, being a consultant and solution developer. So after sort of leaving formal consulting, I went out on my own and have sort of crafted my own little piece of the world in AI, and mainly consult with banks and hedge funds, as well as some private clients. So, and yeah, here to sort of impart my knowledge along with Dan as well, to all the war stories, right up to strategy, solution development, and putting that sort of industry lens on what you guys are learning through the week, going through the modules.
Yeah, cool. So looking at the first module there, it's really a good kind of level set. What do people mean when they talk about some of these terms? Like, I think when a lot of people come into this space first, they see AI, machine learning, deep learning, neural networks, all kind of bundled in together, and it's actually quite confusing. And they use them interchangeably, and while that might seem quite convenient, I think what we're doing first up is really kind of level setting what they mean and how they're different, and where one might sit inside the other or relate to the other. I found that to be really useful. Oh, we've got a new attendee. Hello. So I guess the overarching concept of AI is a good place to start. Let's start with that one as a concept. And then when we define that, we can think about the other ones, and Sam will talk a bit more about machine learning in a minute. So AI is really something, a piece of technology or a domain that really allows technology to behave as if a human would. And that's a really broad statement. That's a really broad definition, but I find it really useful because it allows us to encompass quite a bit of what we're actually talking about here. We're talking about chatbots, so we're talking about making predictions, but really they're things that humans do. But if they're things that we can get a computer to do, and we're doing it without any human intervention, then that's generally an all-encompassing term around artificial intelligence. Would you agree, Sam? Does that feel comfortable for you? Like, I find a lot of people have a very, well, not very different, but slightly different definitions of AI, and that's okay. But, you know, if we can talk about that and bandy that around a bit, that's okay.
Yeah, I definitely agree. I mean, AI is one of those things that, you know, I mean, the classical thing we all sort of, when they first encounter it, they think of, you know, smart robots, Terminator, self-awareness and everything like that. But as we break it apart, we do see there's different fields of AI itself, but also there's that overarching principle, as you said. So to get a machine to, you know, mimic or encompass human decision making to an accurate degree. So definitely agree with the definition you just provided.
And what about machine learning? I really like the contrast between what we're going to talk of here in this course around AI and what actually machine learning is.
Yep. So, I mean, I sort of see machine learning as your first kind of like port of call in this sort of space. I mean, machine learning, you know, being the first kind of touch point for a lot of clients, a lot of people entering the field. I mean, it's so vast. I mean, everything from, you know, we've all heard of decision trees right up to random forests and clustering analysis, you know, regression. It all encompasses machine learning. And machine learning really is that sort of, I would hate to say low level. I mean, low level compared to deep learning and AI in general, but nonetheless still very valuable to industry and complex in its own way. But still that's at a low level, saying, you know, looking at features of a data, can we classify future occurrences based on what, you know, we've learned and based on mathematical principles that we've applied on the model that we've applied to. So, I mean, yes, it is a sort of vast landscape, as I said, and, you know, encompasses, if you look at a sort of Venn diagram, they all kind of intersect with one another and all encompass that data understanding and engineering, you know, on top, but definitely playing in different realms and, you know, probably on the bottom of the hierarchy, you know, I would say in terms of sort of sophistication and complexity. Oops, sorry, Dan, I think your audio has gone out.
There you go. What about the role that data plays in machine learning? Do you think that's important to the definition? Or?
Oh, yeah. I mean, this is, if I had to put an overall theme, I would say, you know, a takeaway lesson approaching any machine learning problem or machine learning domain is good data understanding, and domain focus. So, you know, you're always going to have a domain focus looking at whatever industry you're applying for. I mean, looking at the student cohort we've got here, we've got, you know, everyone from food service to education to retail, telecommunications and government. And any model that you put forward through with machine learning or artificial intelligence or deep learning will always have a domain focus. I mean, that's the end consumption, that solution, whether it be a prediction, whether it be prescriptive analytics, whether it be any sort of forecasting sort of model. And that sort of brings into that, you know, data understanding and that sort of good data, you know, garbage in, garbage out seems to be the overall encompass for any data scientist or software engineer, anyone playing in this space. I mean, you know, loading in data that is irrelevant to what you're trying to achieve or has not been engineered or cleaned properly can sort of, you know, send your model, you know, in lots of different directions and obviously a lot of, you know, adverse outcomes. And that comes into that sort of data understanding. And, you know, you don't have to be the most technical person in the world to achieve a high level of data understanding. It's really looking at the data itself and seeing what's important from a business focus. And, you know, people approach it in different ways, but a lot of the time it is looking at, you know, what do we already know about the business and what do we want to know and what can the data tell us and how much more data do we need, you know, and that sort of building on from that is those further themes of, you know, looking at your knowledge of the models, like what is the most suitable model to start up with, but then that sort of leads to that experimentation that business measures, you know, how do we measure performance of any model or any solution we put in, and can we keep iterating, you know, forwards from it.
Right.
Yeah.
So, so some other areas of the content here talking about AI is a really good also way to help us kind of categorize the different kind of tasks that we can achieve with AI systems, whether they be machine learning systems or just, you know, other things that look like a human might have made that decision. I think that, that there's some really good content there that should help drive a lot of use cases. And yeah, I agree. Like seeing the cohort list there and how broad it is through all those different domains, it's going to be really exciting to see how everyone starts to develop, you know, their use cases around AI and machine learning. There's a lot of, so I'd really look at those different categorizations. So there's one of the sections there, it's got things you can do with AI and ML, and all of those different areas, you know, talking about machine translation and context extraction and content categorization. It'd be good for you to stop and think about your domain, and if there's a problem in your domain that could really use some AI in that area. Do you have some data in that area, or do you have some decision making in that area that you're looking to automate, I guess, through AI?
Yep, definitely agree with that. And I mean, it always sort of has that strategic sense, you know, in sense of approaching this. I mean, you know, it's always that defining that business problem. So looking at your, you know, industry or your business that, you know, you either own or work in, and defining that business problem, like what is something that we need to sort of improve, whether it be customer satisfaction, whether it be reduction of forecasting errors, whether it be looking at predicting customer behavior, you know, itself, or recommendation systems, you know, and then sort of approaching that from a sort of consulting and strategy lens. You sort of look at that business problem, you say, well, who are the stakeholders involved here? I mean, who are the owners of that product? Who are the people that are going to benefit from those realized advantages of any AI or machine learning, you know, solution? And then a part of that as well, if you have to break that down even further, it says end users. Is this something that's going to sit in a back-end system and just push out a metric onto a dashboard? Is this something that's going to be mobile applications interact with end users? Is this something that, you know, will be updated every day, every hour, or, you know, every week? And then you sort of go into those sort of technical requirements, you know, data landscape, you know, what data do we need? What data do we have? And what data, you know, would we like to have? You know, and then looking at that sort of defined technology landscape, you know, on top of that as well, you know, do we have the necessary systems and environments needed? You know, and obviously Dan and I can both talk to that based on our experiences. And, you know, it seems to be that rule as you get more sophisticated, you know, with your tool sets, when you move from machine learning to deep learning to AI, the tool sets and the environments become more complex and the computational power becomes more complex. So that always needs to be encountered, any sort of strategy to say, what is the cost to the internal business or the client that I'm delivering this to? And then, you know, and then there's a sort of the model choice as well, you know, and as we sort of touched on before, performance measures, you know, defining that business from what kind of performance measures are we going to have, you know, to measure if we're going to continue with this approach or not. And that sort of comes into that strategic roadmap that is all encompassing element on top. So, yeah, I mean, that's the sort of like approach, and that's sort of where we go with machine learning, looking at those use cases, you know, everything from computer vision to text or natural language processing, or just simple classification, anything that's going to have that strategic lens as well, that buy-in from any internal or external stakeholder.
Yeah, right. So we do have a question in our Zoom channel, actually.
Yep.
Just around the exercises and asking how that could be applied to your organisation. So someone's just asking, what point of view does that have to be? So if you don't have an organisation that you want to apply it to now, can you choose one? And I guess probably the you know, the short answer to that is you can. So you don't have any real use cases, but I think the best way to get what you want out of this course is to actually choose a domain. Choose one that, obviously, if you're in a domain at the moment or organisation like, you know, power or finance, choosing that is probably going to be easier because you'll be able to think about that. So it's okay to make one up. if you want to choose finance or something that you're the most comfortable with, then the ideas will flow a lot quicker. So, maybe think about some previous employment, or even the education sector, if you want to apply it directly to what we're doing now. Think about that sector, and then you can apply that to all those questions to the exercise that works. Choosing a domain, I think, would help you tease out, I guess, a core set of use cases. I've been through some of these before as well. Like you can either go, I want to choose a problem for text, or a problem for vision, or a problem for recommendations. But I've found it really helpful to go choose a single domain, choose finance, choose education, choose power and energy, and try and think about those sort of things.
Yep, I would agree with that. I think it's good to sort of like look at that sort of industry sector, as Dan said, sort of finance or government, but then sort of drill down, and this is sort of, as the course goes along, you'll start to sort of develop more sophisticated knowledge to start to drill down and flesh out your own idea. So, the idea you have now and the approach you have now will obviously drastically change as you start to learn more about, the nitty-gritties of, AI strategy and the technology advantages, and obviously the limitations and risks that come along with that. So, starting off with something like broad, just saying finance, and looking at some use cases that might be in there, whether it be sort of customer enhancement, credit profiling, forecasting or algorithmic trading, and then, moving on from that to say, well, if I had to formulate a sort of top level or, up in the cloud strategy, what would that look like? And that could just be a simple business measurement saying, I want to enhance the way my customers interact with my business, but in an automated fashion. So reducing those call centers, and so forth. And then as we start to develop on, you start to look at what data do you need, what technology you need, and then obviously maybe multiple, systems might become involved. So starting at a high level, and you can make it up or approach it from your own organization, but it's an evolving idea as well. So, whatever you sort of come up with now obviously might appear very different at the end.
Sam, we had another question, which is really good because it plays straight into, we talked about defining AI, talked about defining machine learning, but someone's asked, can we explain what deep learning is? Do you want to attempt that?
Yeah, sure. So deep learning, that's the sort of, looking at that hierarchy again, if we had to sort of play on that example of mine, deep learning is that next step towards, artificial intelligence, or what we would call, sophisticated artificial intelligence. So deep learning utilizes neural networks. So looking at, more vast patterns in data. So then, big classic examples of deep learning systems is, image recognition. So breaking apart an image into elements, and those elements can be strengthened as it moves through a network of neurons, and then at the end can classify it. So then when it looks at future occurrences of that image within training and obviously prediction, you can use those same weighted elements as it goes through. So say a toy example is the cat dog recognition, and that uses convoluted neural networks. Don't worry if you don't understand convoluted neural networks in definition at the moment. I can link some things on Slack. But basically it means that things are connected in a certain way based on the weights that the image is broken apart into. So then it'll sort of look like what a cat would look like in an image. So that would be ears, whiskers, body position, and so forth. And then it basically breaks that image apart into different layers. So then it can train on and strengthen what a cat looks like in terms of patterns of data by breaking the image apart. The other example is recurrent neural networks, which is big for text processing or any sort of sequential data, and that looks at ordering of data as it goes through. So that can be sort of time series, it can be sentences, it can be your chatbots and so forth. So, that's very high level. Deep learning is a evolving domain, ranges from now sequence to sequence learning, which is translation systems, generative adversarial networks, which is image building, and can do everything from building songs and so forth. So yeah, I mean, that's a very high level, but I suggest definitely, like, I'll post some things on Slack. And if you want to drill down more into what deep learning is, I mean, obviously, Dan, I can open the mic to you to sort of explain it if you've approached it from a different lens as well. But
yeah, I really like to. I find it helpful to think about what it isn't, or what groups of things sit within machine learning, and then that smaller group that might sit within deep learning. So machine learning to me, encompasses all those things around teaching machine to do things with data, so it can make predictions in the future. And you can do that really, really simplistically with some really simplistic mathematics. Just the really simple examples are things like predicting house prices by using the number of bedrooms. So if it's got 2 bedrooms, the house will sell for $300,000. If it's got 3 bedrooms, I predict this house will sell for $400,000. This is a really simple machine learning kind of problem you might come across. Whereas deep learning will use a lot more sophisticated techniques to make that prediction. It will use a lot more inputs typically to make that prediction. It might look at, I don't know, the weather pattern on the day, and those sort of things. And they become less explainable to us at the moment. It's so deep, I guess, that when you feed all of these things, all of this data in, and the machine does some learning on it, then we start to lose our ability to understand how it's making that prediction. And I guess this is really kind of, to your point, Sam, it's an evolving area still. Can we explain how these predictions are being made? Like, it's becoming quite a challenge for us to do.
It's true, and that's that sort of element of, and we don't want to sort of get too overloaded technical on deep learning with the first sort of lesson, but this is where that deep learning, they talk about the hidden layer of deep learning, and this occurs, as Dan said. Deep learning uses back propagation, so basically pulls its errors back through its network to correct itself. So you can think of it like it's iterative learning how to become more accurate in what it predicts. So as Dan said, if you're looking at even a house price element of deep learning, it might start at a very top level in terms of bedrooms and so forth, and as it goes down and down and down and starts adding more propagating layers for itself, it starts to become more sophisticated and saying, well, now there's minute data points that keep adding into the sort of outcome to make it more accurate. And this is measured through cost reduction in terms of the difference between a predicted and actual case. But as we said, we don't want to sort of get too overloaded in this, and we can sort of point back to Slack and we can post up some things of some approaches. But, we do have another questions around Facebook using image recognition to tag people, and then self-driving cars and obstacles of roads. Yeah, that is a form of deep learning. It's a bit more ensemble in self-driving cars. There's a lot of data points that come through, from LiDAR to, cameras to road conditions. And obviously each approach would be yielding different results. But in terms of, on a top level, Facebook recognition uses deep learning. You're breaking apart the elements that make up people's faces, so it can predict the next tag face when you're in a picture. But yeah, I mean, this is something that we can explore more on Slack, and you feel free to post up, questions based on if you want to get sort of more deep dived into deep learning.
So, Sam, one of the interesting line items you put on what we might want to talk about tonight is where we see AI in 1, 5, 10, and 50 years. I thought that was pretty bold. Like, if you got some, you want to start with that?
Yeah, and I mean, this is sort of, looking in, I mean, as any sort of AI strategist or any business implementation, we can't just build for now, and AI and, machine learning and deep learning will continue to evolve. I mean, the minute it went open source, once Google released TensorFlow, to be open source, and then, it just boomed in terms of everyone around the world starting to build examples on what it could look like and, toy approaches, we start to understand that this is not a static field. It's not something that will just be built and forever do its job. As customer preferences change, as the world of data changes, and as we've seen recently, big data, was the buzzword of 5 years ago and 2 years ago even, but now it's fast data, and now we're moving into more of the smart, data landscape. So where we sort of see it, if we started to put down a timeline, AI evolution and deep learning evolution and even machine learning evolution will always be linked to, kind of three facets. One will be your technology landscape. And we saw deep learning got the revival it did because of the graphical processing unit. People started to access better computing power easily. And then, the growth of data itself, and this is that sort of second element, more data becoming more available and the ability to do bespoke or sophisticated analytics and models started to become easier, just because we had access to larger amounts of data and, wider amounts of data in terms of attributes and characteristics. Then I guess the overarching thing will be, as other industries move along, we start to see the clients we serve now and the customers or employees that we serve now, their interaction with technology will continue to grow, through smartphone usage, through augmented reality and virtual reality gaming systems, through awareness in the media and other services. So we're forced, to continue to evolve. So, where we look at it now in the, in this last sort of year, Tesla with its self-driving cars becoming, more apparent. It's just the mainstream now. You see them driving around Melbourne, Sydney, all over Australia, but then we're starting to see, Boston Robotics and Dynamics coming out with, Atlas and the automation in that sort of terms. And we look at Amazon and their automated warehouses and drone technology. You start to see the evolution, becoming more apparent and becoming more acceptable. If I had to sort of put down my milestones, and obviously Dan and I might have differing sort of things on this, but this is what makes an open source world is AI, beautiful, because everyone has their own approach. I sort of see it as, right now it exists in a sort of consumer lens. Like, we see AI technology and deep learning technology in the consumption phase, everything from, Alexa, Siri, Google Home Assist, Tesla self-driving cars and so forth. But, where I see it evolving is that more, business intelligence, that people will start to become more comfortable in letting businesses become more automated, whether it be more virtual assistants, whether it be credit ratings, whether it be product delivery, will start to become more automated for society. Yeah. If it's time, who knows where, we all exist. I mean, we were hoping as the technology starts to evolve and, computer processing evolves and becomes cheaper and, easily accessed, we might see more, home assistants taking different forms. I mean, one of the more interesting things I saw was the home cook, the deep learning robot that can cook you now pasta, soup and all this stuff, automated kitchens. This is just coming out of, toy examples coming out of universities, but, could be a viable market in the next sort of 10 years to, 20 years down the track and even sooner. So, Dan, I mean, I'd love to hear as well.
Yeah, it's pretty exciting. The one that I agree, fully is around automation. A lot of this AI world is around automating tasks that humans do now, because, as we talked about in the initial definition, it's about doing tasks that we would perceive a human to be able to do those. And so in the near future, the 1 to 5 years, you're definitely going to be seeing a lot of tasks that you might even not be aware that's being done by an AI is being that you might think is being done by a human. So what we'll start to see in the next 1 to 5 years is those typical kind of chatbot interactions where you might ask a few questions and then a call's redirected. But what I'm hoping to see, and maybe this is more about my hope, is that they become more fluid and natural, as opposed to us interfacing with a computer system, and it comes really kind of jarring where we feel like, press one, do this, type that. It becomes more of a conversational, natural interface for us to work with. That's what I hope to see in the near future. Well, in the 5 kind of year mark. In the 20 to 50 year mark, there's a lot of talk you might see around general artificial intelligence, which is just this concept that there's an artificial intelligence that can replicate the human brain and take arbitrary inputs and be able to reproduce the way a human would in situations that it hasn't seen before, at a scale and a complexity that a human would maybe in 50 years, but I don't know. There's people working on that, and it's fun to read. I guess I'm too much of a pragmatist and to really think too much about that now.
It's true. And I mean, on this note, we can sort of say that, we've kind of put it in a lens of what's possible. But, being that we're a strategy course, we should sort of look at, bringing it back to say, well, what are the limitations that exist now and us getting to the utopia? This is important that, as we sort of talked about that client buy-in or that pitch, and, developing a strategy will always list out any risks or limitations. And, we see a lot of things going on in business at the moment around sort of machine learning and artificial intelligence and deep learning. But, there is that sort of big question, that divide to say, well, here's a company such as Tesla and Microsoft and Amazon using deep learning and artificial intelligence to its near limitations that we've sort of perceived now in our current time. But then why does my local bank still direct me to a person to call? Why is the chatbot on my app, so awful? And this is where it sort of sees where, that evolution of business and where legacy systems and behavioural change has to take place as well, to move, historical business practices into a more automated and technology-driven environment or data-driven environment to allow for deep learning or machine learning on any sort of scale will require huge overhauls of people, technology, access to data, as well as sort of breaking down elements of privacy, as well. And, looking at different behaviors of customers and clients and general society, there is that sort of resistance to machine learning and AI in general. That human touch can be a cultural element, across generations where people feel more comfortable interacting with, a human rather than a chatbot. And, elements of more sophisticated machine learning might plug this gap where, natural language processing takes the next step. But we do have to sort of look at where we are now and strategize how to get there in the future. And, there will be companies that move very fast into this because they're sort of equipped and ready to take that experimental agile approach into this new technology landscape. But, in terms of adopting it society-wide and business-wide, there will be that sort of element of how do we get the monolithic business that existing on legacy systems or legacy practices to move into an automated world? What strategy has to be formed in doing that? And this is part of that sort of design thinking that you guys are doing now for your course, and saying, how do I approach a business problem of my own creation, but also what risks and resistance would I find that might be in there in terms of technology costs, change management, adoption, and sustainability for the business? Well, will this change the way my customers interact with my business or my clients interact with my business? Will customer satisfaction suffer, and so forth?
You touched on a point there, Sam, that reminded me about what we kind of wanted to bring to this course. And I see a couple of questions in the chat. We'll grab those in a minute. But one of the things we wanted to bring is I guess a dose of reality. Like, we've been doing this in the real world, so we're going to work through some use cases here, but we want to give you a dose of, and this is what's practically possible. So I guess we want to lean on that experience a bit and, share some industry experiences and some successes and failures and constraints and boundaries. And is there some stuff we can share tonight I guess, go through some of those examples
No,
now.
I think it'd be a good sort of point to lean on sort of a use case that we've both kind of encountered, in our respective fields and respective sort of clients, just to kind of put a little bit of context around all these ideas and concepts we're throwing out there. So I worked on a AI case with a retail bank looking at fraud reduction. So this was in the sort of domain of reputational damage, looking at saying, well, fraud itself within a bank, a lot of people think it is monetary damage, and it is. There's a vast landscape of monetary damage, but small amounts of fraud can also be a reputational risk, to a large organization. And, it doesn't have to be finance itself. It can be any organization, it can be government, it can be retail and loss prevention and so forth. So, they were isolating to say, well, looking at a business problem, and this is going back to what we talked about, framing that strategy in the current landscape, or what we call lay of the land, there's a lot of manual intervention in looking at fraud. So it's a very sort of reactive approach, looking at transactions that have already gone through a system and trying to isolate anomalies, through there. And obviously data analytics played a huge part of this, and, machine learning played a part of this for a while as well, but they knew they could obviously be faster, in capturing this. There was also that problem of dealing with multiple systems as well, front end and back end systems, saying what goes in a retail sort of front end local branch to what happens in the sort of back end systems. So as a consultant, my job was to sort of, get that buyer, stakeholder sort of buy-in to say, well, if we need to develop something over the next sort of 1 year to 5 years, we need that initial inception of the client interest to say, this could be a journey. It's not going to be a solution that you might take off the shelf and sort of plug into your organization. This is going to be something bespoke and characterized to the type of, business you guys run and the type of customers and problems that you face. So, looking at this sort of framing required a lot of domain expertise and also a lot of isolation in terms of, we didn't want to solve the world initially, just because there would be a lot of data that would have to be poured through and we might not be able to achieve it in time. So we sort of looked at, isolating a use case, and, we looked at things like pay slips, we looked mortgage applications and so forth, and started to say what elements could be at risk, from this, signatures, company logos, addresses, names, and so forth. And then how could we apply deep learning in this case to kind of solve, some of these issues? Can we start to say, what is a, company logo normally look like versus what's an anomaly look like? So as we sort of went through, we sort of said, well, here's a client that's not going to hand over data willy-nilly, at the start. They're not going to give us the data we need. We still have to get that buy-in. So we sort of looked at a novel approach. We said, well, what is something we can do that would entice them to go down this path further, something that we can prove? And, we started off looking at, cats and dogs. We said, here we're going to face an audience that necessarily doesn't have the sophistication around deep learning that we might have, but we need to show them that this is not just an unreachable technology. It can happen, on a laptop, it can happen, within their own business. So the initial sort of buy-in we looked at is an interactive display around, classification between different dog breeds and different types of cats. That got that initial buy-in to get us to that next stage of the journey. And then we looked at prototypes around isolating signatures within fraud to say that if we could learn off of someone's signature and augment that data, going forth, we can start to pick up fraud. So this is that sort of approach around agility in experimentation. As we went forward, we could sort of isolate those quick wins with that client, and they could see those iterative gains as we sort of went through until we got to a point where we could start to deploy more of a sophisticated model. Although, this solution itself, I played, you could say a 50% role in, because I was sort of inception going forwards. It still was at that stage of like, how do I get that first buy-in? And this is something that you guys will all face as well. We all kind of want to jump to that end solution to say, yes, this is how we're going to solve it. It will be solved in 2 years' time, it'll be solved in 1 year's time, and it'll require me, $10,000 to $10 million, depending on the sophistication, of what we want to build. But it all starts with that initial idea. And, in this space, it can always be something as simple as a toy example or a small scale example, looking at maybe one feature in classification or looking at sentiment analysis in a small subset of the data. So, this is something, as I've sort of touched on, numerous times tonight, is around framing that business problem to say, what is the simplest approach I can do now, and how can I build on for the future to keep addressing that core business problem that I'm trying to solve?
Yeah, that's awesome, Sam. I really like the focus on experimentation, and I think this is a really good point to get across when people think about building an AI strategy, is really understanding at its core that you are building experiments. So the example I'll use, we did a similar thing, and we do other projects like this as well, is that we don't, a typical digital project, you might go, we're going to build X and it will take 2 years and 10 people. And we just know in this field that that's not feasible. All we know is that we can have a hypothesis, that we can attempt to either prove or disprove it. And if we do that in a short period of time, then it allows us to correct course or say yes or no to what we're trying to prove or not prove. And this has been a recurring theme in all of the work we've been doing around AI, is that we need to do short little pieces of experiments to determine, are we on the right track? Do we have enough data? Is this a viable piece of work for us to go forward? So the example I'm going to use is that we had a client who had a bunch of work that was being done manually. So they had an inbox that was getting filled up every day of images of electricity meters and gas meters that customers wanted to read. And someone would go through and check them and enter them in every day. So it involved opening an email, looking at an image, and entering in those values, or going backwards and forwards with that customer to determine what that value might be. Maybe telling them, no, you're looking at the wrong meter, or that's not a meter, or that's a water meter, those sort of things. And so we had two things here. One, an opportunity to automate that process. And two, we had data, because there was already an inbox full of images and outcomes, what that data actually meant. So we used those two things to actually train a model. We took all those images and those outcomes and built a model. And then we went the next step and actually took that model and actually put it in a mobile device. And so we allowed the experiments we're doing at the moment is allowing them to take a mobile phone, and that model is actually running through that prediction in real time. So every frame it sees, a customer can point it at a meter, and we read a frame and go, we think the value says that, or we don't see an electricity meter, or that looks like a water meter. And we do that each frame. So that's occurring maybe 8-10 times a second. And we give that feedback to the customer then. So the customer's actually getting feedback 8 times a second instead of this email inbox approach, which they're getting feedback around what their electricity or gas meter says every second day when the person can actually get to it. So those sort of examples, and through experimentation, we're getting further and further through this as well, are things that I guess we want to bring to the table, kind of, how they work, how we got there, what the constraints are, what are the sort of the things that we're finding in terms of, okay, this is not working now. Because we've also done projects where customers come to us with a hypothesis around, we would like to predict when our servers are going to crash, and we have a bunch of data. So can you go do it? And what we do is we just do 2 weeks worth of work to say, okay, let us explore that data and see if we can come to a conclusion or not. We do these little 2-week pieces of work to say, okay, we might have enough amount of data. What things do we think could help us predict that? Okay, maybe these 3 levers are the things that help us predict that. And then the next 2 pieces, 2 weeks worth of work might be, let's try and build a model and see if it's accurate or not. And then that helps us guide or not guide where we go. And in that, this recent example around predicting service outages, we decided we didn't have enough data for that. And so we don't have to spend, 9 months worth of work to actually get to that resolution. We can do that really quite quickly.
And I would agree. I mean, this is sort of that point we sort of say, Dan, and there is this sort of business lens into it, and experimentation falls so well into this, because when you're measuring performance of any solution, and it is a journey for the implementation team, the consultant, as well as the internal stakeholders or client, it is sort of measuring what does success look like going forwards. And
great question.
Exactly. It's sort of in my approach with my sort of banking client, it was a case of first getting the buy-in and then getting these sort of small wins in every kind of 2-week iteration going forward. So let's look at one data point being a signature, and then kind of isolate the next point being the company logo and so forth. And in your point, it could be elements of like, okay, let's look at the water meter and then sort of identify the next element going forwards. And this model becomes more iterative and more successful, but also the client can see that evolution, as well. And this is, that sort of point, in any strategic approach has to be transparent, going forwards. It has to have an input, because, success can be measured in so many ways. And a lot of people see it as, a cost saving to a client, but it can also be customer satisfaction. It can be usability as well. I mean, putting a model in a mobile device increases its usability, 10 to 100-fold, versus a back office operation that maybe no one sees. And this is where, each domain and each industry are going to have a different approach. A chatbot, is successful, but is as necessary, because maybe we can do the same operations, in the background. It's sort of that soft touch approach. And this will always be in any strategic thinking to say, well, what does success look like? What is the impact to the business? But also, what does that journey want to go on? Do we start something very simple, like I did, a cat dog approach, to get the interest peaked in, deep learning so we can go forward? Or do we go radical and build a, sophisticated prototype, straight up, and get them to buy into that straight away? And this will always be shaped by the sophistication of any problem you're facing, or any industry that you're sitting in. Some industries will be more adaptable to these ideas, and others might be more resistant. So always going to be that strategic approach to how you get that first foot in the door to start allowing that experimentation to go forwards.
Yeah, very important. Experimentation, and what does success look like? We ask ourselves that every single time we kick off one of these things, and how it relates back to a business objective as well. Success from a business objective point of view. What does success look like? Because as technologists, there's we might say, success is 2 standard deviations from the mean, or something like that. And no, like, what does it mean from a business objective point of view that success looks like? And we need to translate that back up so it aligns with an AI strategy. Yeah, good.
Exactly.
So there's a couple more things we want to cover tonight. Obviously the weekly milestones, and also any questions you have. Just to address some of the questions that I'm just seeing in the Zoom chat here around ethics, which are really interesting. So these ethics questions I've seen coming up more and more. One of the reading books at the end of this module is from Alan Broad, that touches on some of these points. There's also a lot of discussion happening in the community around this as well. So there's a lot of responsible AI meetups being set up. I know there's one up in Melbourne being set up where these discussions are being raised, particularly things like, is it okay to scream at a robot? And it's a really interesting discussion. And when you take it to the nth degree, you're like, well, it becomes whatever you think it is. But I think the good thing is that there's a discussion taking place around this stuff at the moment. And also the ethics of of the data we're using to drive some of these decisions as well. So I think you'll find a lot of that in Alan's book around making predictions around if someone's going to re-offend or not in a justice system, but what are the things we're using to drive that prediction. So I'd really recommend, if you're interested in the ethics of AI, take a look at her book.
Exactly. And, you know, if we have to sort of bring ethics back and into the sort of business lens as well, and something practical that you probably encountered as well, Dan, in your journeys is, you know, at what point do we hand over complete decision making to a machine? When humans step away from that decision? And, you know, suggesting a Netflix movie that you might want to watch next is a very soft touch. I'm sure that, you know, we can all forgive a machine for suggesting a show that we don't want to watch. But when it comes to, you know, denying a mortgage, when it comes to, you know, outcomes of a criminal justice case based on, you know, analytics, at what point do we allow complete automation? And this sort of brings it back to those use cases as well. You know, whatever solution you'll put in, you know, think about it as saying, can this be a solution that can be completely automated? What are the ethics around this? What are the adverse outcomes, you know, if the system's wrong? This always forms any part of a strategy when approaching a client, because, you know, complete automation is something that clients probably like and businesses like, because this allows cost saving, but it also is the risk of reputational damage and customer, you know, satisfaction can suffer as well. And this is something that falls into ethics, as Dan said. The data we use, I mean, the more data, the better in a lot of these models, but some people may not be comfortable in handing over the data needed to make that model a bit more sophisticated. So is there a way that we can bootstrap a model to allow for those like lost data points? Or is there a way that we need to restructure the way we do our business to allow for, you know, AI, you know, to have that automation maybe needed by some businesses themselves?
So there's also a question here around examples of AI being used in government policy setting.
Yeah. So we had a sort of interesting case back in consulting around this, and policy setting is sort of, you know, it obviously depends on the flavour of the government, you know, running this. And I mean, it can be very simple as, you know, machine learning clustering around, you know, voting forecasting around where do we think certain people will lie within an election, but also where do we think certain people will lie based on their characteristics to a new policy, you know. And we've seen machine learning back in consulting used around looking at attributes of people living in certain suburbs to say new zoning practices, you know, coming in. We've looked at migration policies based on sentiment analysis from tweets and forums and so forth. And there's so much data, you know, there, but, you know, this sort of sits in that sort of, you know, forecasting setting. I mean, the most interesting sort of AI-driven example within that policy setting is more around law. I mean, there were use cases of law firms investigating AI, developing law cases for them based on mining down, you know, previous examples and so forth. But policy setting itself in terms of automation is more around prediction from what I've encountered around saying, you know, based on, you know, voting behaviour, based on reaction to previous policies, what can we predict the next policy outcome would look like, and how can we shape that policy to have a less adverse outcome or a greater level of adoption.
Right. Oh, something else in Slack there. The other thing that we just wanted to cover tonight is talk about the weekly milestones briefly here. So milestone 1 is really being able to feel confident in your explanation of AI. Like if you're presenting an AI strategy to stakeholders, you're going to have that succinct 2-minute explanation, and also understand and explain why machine learning is important in AI as well. So what part does that play in AI? And lastly, the last piece there is really forcing yourself to list or come up with 5 ways in your domain or your organization or your industry where AI could be used. And I'd really encourage you to leverage those different areas that are in the course material that talk about classification or prediction or time series or any of those different things. Just look at each one of those and think, is there an answer that we look for in our organisation? Is there data that we have that could support this in my industry? Or is there some automation that we could do in this area?
Yeah, and you complement that with that first sort of primer is looking at those current processes, saying what are we currently doing and what does that look like in a term of a flow from inception of that idea to the end. So in terms of a customer, what is a customer journey through my business, or in terms of forecasting a report, what steps do I currently take or we take to forecast that report? And then using what you've kind of picked up initially in this first module, you can start to isolate maybe small parts of that business problem, or maybe the whole business problem itself, and saying, well, maybe this part can be automated. First up, maybe that the data that we initially manually handle can be automated. Maybe we can enrich this by using some visual data and using image recognition as well, and sort of breaking that business problem up into a more kind of approachable step into say, well, this is how AI will look within this current business process, and this is how I can apply it to my greater business.
So is there any more questions out of that, or we're happy to take them on Slack? It would be good to get the conversation going in Slack a bit as well. But beyond that, I wish you all the best of luck, and looking forward to having a chat with you further through the course.
Definitely. And I'll post up some of that deep learning material, and Dan, you feel free the same as well. For those who want to kind of explore more into that area, we're happy to sort of facilitate that and go forward. But also anyone else who wants to learn more about kind of the context of what we talked about tonight around the AI strategy as a whole, machine learning, and it's sort of where it fits in, and deep learning and what that looks like in terms of focusing back to those strategic business problems, or even just some use cases that we currently, may not realize is a deep learning driven, use case. And this is, part of the discovery process is sort of looking at saying, well, I didn't even realize that I was already interacting with AI in some sort of way in my life. And a lot of people are very surprised in how much AI we actually already are encountering in a sort of consumer preference.
Yeah, right. And lastly, I think I just had a question there about recording. So this is being recorded. Where can you find it? I think Nosh will probably package it up and post it to the Slack group. So if you've joined us live, you can rewatch it. Anyone who's missed it, the recording will be there anyway. So don't worry about that. Great. All right. We'll wrap it up there, and have a good night, everyone. And we'll catch you all again soon.
No worries. And post up on Slack any questions, and we'll keep the conversation going.
Great. Thanks. Good night, everyone.